experiment is called the molar volume of butane. And I'm going to show you the method that's used to collect the gas by water displacement. So in regards to the calculations for this prac, you can consult the Collaborate eLearn lesson notes, but I'm showing you the technique. So firstly, you are going to measure the molar volume of butane gas, which is in a normal lighter. So this is an example of a lighter that has butane. You can see the liquid is at this stage. It's in a state of liquid because it's under some pressure. When you release it from the pressure of this container, it turns into the state of gas. So first of all, we're going to measure how much we had initially in the lighter. So you turn your little scales on, wait for it to zero, put it on, carefully balancing it on this little, and once it's stabilized, you write the mass down. So the mass of our lighter before we started is 13.695 grams. Right, now that we've done that, what we're going to do is get our large 250ml measuring cylinder out of the kit, and we're going to fill it with water. So I have a trough. You can use anything that's big enough to do this with. So you're going to put it into the water, and you're going to try and lift it so that it has no air bubbles in it at all. And then once you've done that, you invert it. And how you can tell that there's no air bubbles is you look at the top, and if you can see no air bubbles at the base, then you've got it absolutely full. Now that's really important, so there's no errors. And you lift it up so that it's still in the water, but if you lift it too high, the water will come gushing out. So we just want to hold it under the water so it's a column of water that can be displaced by our gas. Now this is a tricky bit. So you may need to practice a couple of times, so you may need a couple of lighters, but essentially, I'll just take this finger guard that I have off because I'm right-handed. Unfortunately, got an injured finger. Right, so what you're going to do is hold with this hand the lighter underneath the full measuring cylinder of water, and you're going to release the gas, and it's going to bubble up. So you don't want it to come outside of this, you want it to only the bubbles to be in the cylinder underneath. It will come up and it'll push the water out, and you'll be able to measure the volume of gas that this produces. Now if your lighter actually keeps going and wants to empty, you can stop this at any time, because you're going to measure the gas, the volume difference, the mass difference once you finish. So it doesn't matter where you stop, but if you stopped after only 20 mils or thereabouts, you're going to have more error. So the more water you displace, the better for the experimental data, because it's going to be more reliable. So let's have a go. So we're going to put this, so you don't press the button until you're right under, and you lift this up so you can be under, which might take a little bit of an effort, and then you've got to try and release it. Now you can see bubbles coming up and displacing the water. You just have to have the strength to hold it on until you get a good amount of gas in there, which may mean emptying the lighter, or depending on how much liquid you have in the lighter, might be half emptying it. So don't worry about holding it straight. You just want to make sure that you don't let any gas escape into the water tub without it. It has to be going into the measuring cylinder. Otherwise your results will be incorrect. Of course, you know that butane, being in a cigarette lighter, is flammable, so you wouldn't do this anywhere near a naked flame. So once you start, you can't really stop. It's not advisable, so you really should get into a comfortable position and make sure you can hold it on for the amount of time needed. So you'll be noticing that the water is coming out and you're collecting the butane gas. So whenever they say in a method, collect the gas by displacement of water, that's what it means. So you really should keep going. Get a little bit more. Ideally, you'd want to collect at least half of this 250 ml measuring cylinder as gas. So it's a bit of a waiting game. And if you do this accurately, you will prove the molar volume of gases, which is Avogadro's law, that 1 mole is exactly 24.5 litres at room temperature of 25 degrees, and you do want to prove that. So the more accurate you are here, the more likely you are going to have very close to his results. Because Avogadro's law is 1 mole of any gas occupies 24.5 litres at standard laboratory conditions. Alright, so now you've collected your gas. You take your lighter and you've measured how much exactly is in that tube, and you've written that down. You dry this thoroughly, making sure to reduce the error that there's no water in any of the crevices. Make sure it's really, really dry, and when it is, we can reweigh it so we know how much mass of gas we used, and then the calculations for the prac will be shown in the lesson. So that was Ted, I think, 0, yep. And now we haven't used very much. It's gone down to 13.575 grams. So it shows you how much it's compressed, a lot. And that's all you need to do today. And of course you need to pack up your equipment. Just knowing that this has got gas in it, just let the water drain out. It has to be done in a well ventilated area, and then dry this and put it back in your kit.